This is a brief lecture on how to estimate binomial probability distribution by using normal distribution. We will get a very good estimation anytime n times p is greater than or equal to 5, and also n times q is greater than or equal to 5. If these two conditions are not met, in that case, we can still do the estimation. However, it's not going to be as good an estimate as it would have been if these two conditions were met. The first case we're going to look at is how to estimate probability that x is equal to a. In one side, we have binomial probability distribution, and in the other side, we have an estimation on that by using normal distribution. This is by adding 0.5 to a and subtracting 0.5 from a. In this example, we're flipping a fair coin 400 times. We want to know what is the probability of getting exactly 195 tails. So in this case, we are not estimating. Probability that x is equal to 195 will be the following. N is equal to 400, p is equal to 0.5, and the number of successes x is 195. To do this, we basically use the TI option, binomial PDF, with n, p, and x as the entries, and we calculate that probability. Now the same problem, but this time we want to use normal distribution to estimate the probability of getting exactly 195 tails. First, we compute the mean and a standard deviation. Now, probability that x is equal to 195, we're going to add 0.5 and we're going to subtract 0.5. We're going to draw the normal curve. We're going to label our normal curve with the mean of 200 and a standard deviation of 10. We're going to mark 195. We're going to go half a unit to the right, and we're going to go half a unit to the left. So we want to figure out what this area is. For this, we're going to use the normal CDF. Our lower value will be 194.5. Our upper value will be 195.5 with the mean of 200 and a standard deviation of 10. I'll leave this up to you to compare this result with the previous example. Let's look at another case. This time we want to estimate probability that x is less than or equal to a. On one side we have binomial probability distribution, and on the other side we have normal distribution. So in order to have the a included in the normal distribution, we add 0.5 to a. Using the same example we had, we want to know what is the probability of getting fewer than 215 tails. Again, no estimation here. Probability that x is less than 215 is the same as probability that x is less than or equal to 214. Now we can go ahead and use binomial CDF for this case. Now the same problem, but this time we want to use normal distribution to estimate. When I have probability that x is less than or equal to 214, this will be approximated by probability that x is less than 214 plus 0.5. Again, we're going to go ahead and draw the normal curve. We're going to label it. Mu we already know is 200 and the standard deviation is 10. 214 will be somewhere on the right side, but we want to be less than or equal to 214, so we want to find this area. In order to include 214, we're going to go half a unit to the right to include 214. So this will be normal CDF. Our lower value will be negative E99 because we're going to the left. Our upper value will be 214.5. Our mean is 200 and a standard deviation is 10. Once again, I'll leave it up to you to finish this and compare this answer with the previous example. Our next case is probability that x is greater than or equal to a. On the left side, we have binomial. On the right side, we have normal distribution. Again, we're looking at the fair coin tossing it 400 times, and this time we want to know what's the probability of at least 210 tails. Since we want 210 tails, that means we don't want 209 or less. So we subtract that from a total probability of 1, then use the binomial CDF to complete this problem. Now the same problem, but this time we want to estimate using normal distribution. So probability that x is greater than or equal to 210 is approximately the same as probability that x is greater than 210 minus 0.5. So once again, I'm going to go ahead and draw my normal curve. I'm going to label it. Now 210 would be somewhere on the right side. We want to shade to the right. 210 must be included, of course. In order to include the 210, we're going to go half a unit to the left. So now 210 is in the shaded region. So this will be normal CDF. Our lower value is 209.5. Our upper value will be E99 with the mean of 200 and a standard deviation of 10. Once again, try this problem, finish it, and compare the result with the last example. Our last case is to estimate probability when x is between a and b, including a and including b. On the left side, we have binomial probability distribution. On the right side, we have normal distribution. So on the right number, we add 0.5. On the left number, we take away 0.5. Looking at our example again, I want to know the probability of getting from 185 to 215 tails. This will be probability that x is less than or equal to 215 minus probability that x is less than or equal to 184. And we use binomial CDF in both of them and find the difference. And the answer will be, I'll leave it up to you guys to compute. Now we do the same problem, this time by normal distribution. So as I said, we're going to add 0.5 to the right number, and we're going to subtract 0.5 from the left number. Drawing the normal curve. Labeling it with a mu of 200 and a standard deviation of 10. 215.5, 184.5, and we want to know this area. And to compute this area, we're going to use normal CDF. Our lower value is 184.5. Our upper value is 215.5 with a standard deviation of 200. With a mean of 200 and a standard deviation of 10. Once again, I'll leave this up to you to compute and compare the result with the last one. I hope this presentation helped you guys to understand how to estimate binomial distribution using normal distribution.